Welcome back to math. Now we're going to do the practice problems for section 10 on word problems. Problem 1 says, Bob wants to take his family of 6 to the movies. Tickets for the afternoon show are $7 each, and tickets for the evening show are $11 each. How much will they save if they go to the afternoon show? Well, there's probably a few ways to approach this, but basically we have to come up with some sort of formula that finds the savings for Bob. So that's going to be our variable. X is going to be the dollars in savings. We have to realize that we've got two options here. He can either go to the afternoon show for $7 each person, and there's 6 of them, or he can go to the evening show, which is $11 each, again for 6 people. So we want to find the difference between those is going to be the savings. Okay, so let's say he goes to the afternoon show. That's 6 of them times $7. That's the cheaper option. So the savings can be added in there. And the other side is going to be 6 times 11. So this is the total that he could spend. This is the lower amount he could spend plus those savings. That's what we're looking for. 6 times 7 is 42 plus x equals, that's 66. Subtract the 42 from both sides and we get 24. So he will save $24. I could have also written it this way. 6 times 11 minus 6 times 7 equals x. And that would actually show the true difference with subtraction, which would be the total amount minus the lower amount, and that's the savings. They're both going to give me the same answer of 66 minus 42. And we should really label these with a dollar sign. He will save $24. Problem number 2. What is the area of the following triangle? And we see a triangle with a base of 6 feet, a height of 3 feet. And we're given the formula for the area of a triangle. So let's just fill this in. We already have the formula we need. Area is what we're looking for, equals 1/2 the base, that's the bottom, that's the 6 feet, times the height, that's this. Well, 6 times 3 is 18, and half of 18 is 9. So the area equals 9 square feet. Problem 3. Jimmy collects vintage lunch boxes. He sold 7 lunch boxes on an internet auction site. He bought 4 at a garage sale. If he started with 32 lunch boxes, how many does he have now? This is a classic start, event, finish story, all kinds of things going on and a lot of words to confuse us. But really there's a start, and in fact there's 2 events here, and a finish. And in fact the finish is what we're looking for. How many does he have now? So, he sold 7. That was an event. Selling them would be subtracting them. He bought 4. That's another event, plus 4. He started with, now they finally tell us the start, 32. How many does he have now? The finish. Okay, 32 minus 7 is 25, plus 4 is 29. So now he has 29 lunch boxes. Problem 4. Lorraine is a waitress who earns $8 per hour plus 15% of the food sales. If she worked a 6-hour shift and the food sales were $600, how much did she earn? Well, this is a simple formula that we need to come up with for how much she earns. So, they're telling us she gets $8 per hour plus 15%, I'll write that as a decimal, of the food sales. Now we can fill this in with the if she worked part. If she worked 6-hour shift, that would be the $8 times 6 hours plus the 15% of the food sales, which is $600. How much did she earn? That's going to be our X that we're looking for. 6 times 8 is 48, plus 0.15 times 600, that works out to be 90, equals X. Add those two together, and Lorraine makes $138 in that 6-hour shift. Problem 5. Part of $5,000 is invested in an annual interest rate of 5%, and the rest is invested at an annual rate of 3%. The total interest in 1 year is $210. How much was invested at 5%, and how much was invested at 3%? Well, that kind of sounds like we're looking for two different numbers, and it sounds like we might need two variables, but we really don't. Let's say that we're going to let X equal the amount of money invested at 5%. And then we know that the difference, because this is the rest, so 5,000 minus that X, that's the other part of it, is the amount at 3%. Now you need to know that there is a formula for interest. You either need to know it or you need to be able to look it up, and that formula is principal, that's the amount that's invested, times the rate equals interest. Okay, now that we have that formula, we have two principals, X, and 5,000 minus X. So we need to do this twice and add them together. Not going to be that hard. So principal is X times the rate, and 5% is 0.05, and the other principal, which is 5,000 minus X, and that's the amount that's invested at 0.03, and that's the interest for 1 year, which they told us was $210. Now we just have to solve. This is 0.05x plus. Now consider this. This is multiplication. It's the distribution property. It's a little backwards from how you normally see it, but it still means that this term needs to be multiplied by both of those inside terms. Okay, so 0.03 times 5,000. That works out to be 150 minus 0.03x, and that equals 210. Now look, we have some like terms. 0.05x minus 0.03x, that's 0.02x, just subtracting those two things, plus 150 equals 210. Subtract 150 from both sides, and we've got 0.02x equals 60. Now we divide both sides by 0.02, and we get 3,000. So remember what we found out. X is the amount invested at 5%. That's this amount. And the amount invested at 3% is the difference, 5,000 minus X, 2,000. Problem 6. Alex drove 60 miles per hour on his way to a meeting for work. It took him 2.5 hours to get there. How many miles did he drive? Well, this is a relationship problem. One of the dead giveaways here is per hour. So we have a relationship here between miles and hours. I'll assign one to be in the numerator and the other to be in the denominator. It doesn't matter which way I do it. So he drove 60 miles per hour, 60 miles in the top, 1 hour in the bottom. And it says, how many miles did he drive? So X is what we're looking for if it took him 2.5 hours to do that. So now we just cross multiply, and x equals 150, and we should label that miles. It says problem 7. Shauna is baffled by the following problem. Think of a number, double it, add 6, half it, take away the number you started with. The answer will be 3. Can you write the equation? Well, that's a simple formula that we need to come up with. Let's call this number that we're thinking of, let's call it x. Okay, so x, we start with that. We double it. Well, that means to multiply it by 2, and then add 6. That's easy enough. Half it. Now remember, you can't just half 6, you can't just half this, we have to half the entire thing. That's take the entire thing and divide it by 2. Now take away the number you started with, that was x, right? The answer will be, there's our equals sign, 3. Okay, this looks a little messy, but I can break it down. This is really the distribution property. So I've split this up into two things. So this is 2x over 2. That simplifies to x. And 6 divided by 2 is 3. Minus x equals 3. Look at that. X minus x cancels out, and 3 equals 3. Fantastic. It must be right because our answer here is true. What they really asked us for was this equation, which is on the top. We just went ahead and solved it. Bonus points. Problem 8 says find 4 consecutive integers whose sum is 4 more than 5 times the first number. It's a classic formula that we're going to come up with. And here's another thing that people usually make a mistake with, is when they think there's 4 consecutive integers, they think we've got to have like x, y, z, w or something. But we don't. They're consecutive. So we're going to say that let x equal the first number. They're consecutive. That means that they're like the counting numbers. So x plus 1 is the next one. X plus 2 is the third. And x plus 3 is the fourth. Fantastic. We've got everything what we call in terms of x. Okay, then it says the sum. That means we have to add all this up. So x plus 1 plus x plus 2 plus x plus 3. There's the sum of all that is, there's the equal sign, 4 more than, that's adding 4 to something, 5 times the first number. And the first number was x, 5x. Right, now we got a lot of like terms to combine here. I'm going to underline them. There's 1x, there's another 1, 2, 3. We have 4x on this side, plus 1 plus 2, that's 3, plus 3 is 6. Let's subtract the 4x from both sides. We'll leave that with 6 equals 4 plus x, right? This canceled out. 5x minus 4x leaves us with just 1x. Now we'll subtract 4 from both sides and we'll get x equals 2. They wanted us to find all 4 numbers. So the first number is 2, the second number is 3, then 4, and then 5.